Hello and welcome back to the last episode of the Galton Board series. I have now a completely finished video, so I can start it here for you. And I think it looks kind of nice. I have published this on Reddit, so I'm planning to show you how it kind of did. I began this series with live coding, but I realized for the last parts, it was kind of a lot of optimization and trial and error, so it would be hard to do that on live coding without getting too long. But yeah, you can see it here, and I think it looks kind of nice. You can see that the number of collisions are quite many, like in the end, almost 19 million. So in the last video, I think I ended it with I had built this pyramid and I started to build the tiles at the bottom. But as you can see, much have happened since then. The entire background is now white, and I have this kind of white, black, and blue theme to get it to look nice. I have also, which is maybe the most important thing, I have also made a much more optimized collision system. So before, all the balls that are like falling through the pyramid, they needed to regard every peg in the Galton board. So with a 3D version like this, it became super heavy to run because, yeah, it's like very many pegs, and it wasn't feasible to do computationally. So I now use an spatial index to kind of limit. So if a ball is like at a certain point, it can access the pegs just in its proximity, which very much reduces the computation. And yeah, so it looks like this. You have seen it now, and I have the entire file here. I mean, it's probably not optimal to write the entire thing in a single file, but and it is published on GitHub, so you should probably see the link down below if you want to really investigate the code. I'm thinking that it might be boring if I go through all the details. I think you have a rough image of how it works, especially if you have seen the previous two videos. But I did publish this on Reddit, so I made a post. Let's see, maybe I can zoom in a bit. Like just playing it, and I also added a real life video of a 2D Galton board, which was actually the inspiration for this animation. And I published it on r3blue1brown, and I got 317 upvotes from 47,000 views. So it's decent. I think it definitely got some traction. I hope the concept was like self-explaining enough for people to understand what I was trying to show. I think people here at 3blue1brown are quite math heavy, so they probably did. My best animation for comparison would be, this one, which was animating the mechanism of Fourier series. And that did really good with 2.4 thousand upvotes, so the Galton board didn't do as good. But yeah, it still got some traction, and it was kind of fun to make the optimized spatial index for the collisions and stuff like that. It is also nice that the Galton board isn't like just an animation that like just draws the normal distribution. It actually does the simulation of the balls falling through the pyramid and then ending up with the desired result. So basically a simulation, which is kind of nice. But yeah, that was just my summary of the Galton board mini project, and which was made in my animation library. It's also linked here, which I call Define Motion. Yeah, as you can see, I have a couple of examples here, and one of them is the Galton board with a bit of example code here. But yeah, thank you for watching, and that was it for this project.